Okay, so now that we've talked about the methods, we've talked about the structure, functionality, let's take a look at an example application that kind of hopefully illustrates how the various pieces fit together. So this particular example is called Async Task Interrupted. You can download it from my GitHub repository. And what it's going to do is it's going to run, it's going to do the GCD computation in async tasks. And when the user clicks on the interrupt button here, that's going to interrupt all the async tasks. So I think we've talked about this before. Greatest common divisor is the largest positive integer that divides two integers cleanly without having a remainder. We're going to use async task and a thread pool executor in order to do all of these various computations. Users can cancel the computations at any time just by clicking the little cancel button here. These are floating action buttons, which are all the rage these days in what's it called, material design, the material design paradigm that you get with Android, and I think iPhone is kind of the same way as well. This also gets used when, or one of the other cool things about this is this particular app will let you rotate the phone while the computations are running, and it won't affect running computations, and it'll display them properly after the orientation changes. And that's kind of cool. That's really an Androidism, but it's neat to see how to do that. So it doesn't just totally destroy everything when the phone rotates. It shuts the activity down, but the activity is decoupled from the concurrent processing of the GCD computations. So let's talk a bit about how this stuff is actually implemented. So I'll look through the, I'll sort of show you the overall outline of this stuff, and then we'll look through some of the code. So there's something called Lifecycle logging activity. I like to have this class as a debugging aid, and what it does is it has hook methods for all the typical lifecycle operations, lifecycle methods in an activity, and each of those hook methods will, when called, log that they were called. So it makes it real easy to look at your logcat output to see what was happening as your program was running. It's actually a great way to learn how lifecycle activities work. So that's just a utility class that aids debugging. Main activity, which is what we write, what I write to do the actual work, is going to extend that, and then all of these methods will, all these things will be inherited, so you can tell what's happening. And this method, or sorry, this class starts and cancels async tasks, and while they're running, when they're not canceled, they will repeatedly compute the GCD of random numbers. There's a fun little helper class called async task related state, and that puts all the concurrent entities, the async tasks, the thread pool executor, and so on, that need to live between rotations, between tearing the activity down and starting a new activity. Those things will run in such a way that they do not get destroyed when the activity rotates. So after a runtime configuration change occurs, state's still there, it's been running the whole time, and then we just hook things up and we can keep displaying the output in a clean way that doesn't lose the data. And then, the real workhorse thing here, that the guy that's really doing all the interesting work for our purposes of our discussion, is called Gcd Async Task. And we'll go ahead and take a look at that code here. So this is the directory that contains the code corresponding to the classes that we just looked at. Here's the lifecycle logging activity class. As you can see, this extends activity, and what it basically does is all of its lifecycle hook methods just call up to their superclasses method, which is necessary for the way that Android works, and then just log that they were called, so you can see at a glance what was happening from a lifecycle point of view. We then have the main activity. The main activity extends lifecycle logging activity, so it automatically gets all these hook methods that do the logging for you. You can see here we have some private fields, like the number of times to iterate. If you don't give a different number, it starts out with something like, what's that, 100 million or 10 million or something. We can have the number of threads that we want to have in our thread pool executor. We give it 2 by default. You could have more, but we just do 2 here. There's some other stuff here that deals with the user interface, the floating action button, widgets, and so on. Text view that keeps track of basically displaying the output. We have a scroll view, so as you have large numbers of results displayed. It scrolls nicely so you can go back and see what they were. Here's the async task related state class. As you can see, this has an executor, an atomic integer, a thread factory, a list of tasks, and a constructor that goes ahead and initializes all those things. You can see here we set our thread factory up to create a new thread, and we're going to give it the name async task, and we're going to give it a task number, which is just this atomic integer we increment every time we use it, so it'll automatically increment in a synchronized way. You could also do the more verbose means of doing this using anonymous inner classes, but hey, once we've got lambdas, why would we ever do anonymous inner classes unless we're programming to older versions of Java? Here's where we go ahead and create the thread pool executor, which is going to have 2 threads in this case, no timeout, a linked blocking queue with no size constraint, and that thread factory we made. So all that stuff gets stuffed into this async task related state field, which is part of the main activity. The Oncreate method basically just sort of starts everything up from an Android point of view. It inflates the views, initializes everything, checks to see whether or not this is the first time we've been called or whether this is after a rotation of our activity. That uses something called getLast non-configuration instance, which is what's used to stash away this async task related state. If this is the first time in, we create the async task related state the first time. If it's not the first time in, then we're already running, and then we go ahead and basically tell all the running tasks that we are now the new activity that they should be displaying the results to. And we do some magic with the floating action button to start or stop it to display the right kind of icon. Here's the hook method called onRetain non-configuration instance. This is the one that we use to keep track of the state we want to live across runtime configuration changes. So in this case, we're just returning that field that gets stashed away in a manner that will live beyond configuration changes and activity switching. There's a bunch of code here that initializes the views. I'm not going to talk about this in detail. This is Androidism stuff. Set count, that's some more Androidism stuff. This is an interesting method, start or stop computations. This is the method that gets called when the user presses the right floating action button with the right icon. It'll either start the computation if it's got the start arrow, or it will stop/cancel the operations if it's got the little cancel icon. So if we've got actual things to cancel, we will cancel them. Otherwise, we will start the computations. Let's take a look at the start computations. So start computations figures out how many iterations we're going to have and how many tasks we want to have. And if someone doesn't give the right value, if they give a negative number, for example, we pop up a toast and say, hey, you can't count negative numbers of items. And then down here, we go ahead and make a little stream for 1 to the number of async tasks we want to create. We're going to go ahead and make a new async task with a new ID, with the current ID rather, and with a new random number generator. And then we're going to go ahead and take that async task that we created, and we'll take a look at that async task. We'll take a look at the Gcd Async Task class in a second. We take that async task and we execute that async task on our executor. So we've made an executor that has the right thread pool characteristics, and then we execute that task on the executor for the count for the number of iterations we want to do. We collect all those things up into a list. So now we've got ourselves a task list. These are the list of tasks that are up and running in the background doing the computations. And then we'll update the floating action button to say, okay, now that we're up and running, if you want to cancel us, press this particular icon. If someone presses that particular icon, then the cancel computations method gets called back. And what we do is we simply go to the task list, and for each element in the task, we're going to cancel the task. And we pass in a true saying, if this task is running, shut it down. I want to cancel it even if it's running. Okay, so those are basically the key concurrency-related methods. There's also some other stuff in here that handles life cycles and rotations and stuff for Android. Let's now go take a look at Gcd Async Task. Gcd Async Task is an async task. It has an integer that's passed to the do in background method. That's the number of times to iterate. It has a string that's used to pass on progress update. And it has a Boolean that indicates whether we succeeded or failed. So we have a few fields. We have a random number generator. We have this thing called a weak reference. I won't go into that in detail right now. We have the particular async task number, just so we can use for debugging purposes. The constructor assigns all those things. Set activity is called after a runtime reconfiguration occurs to say, treat this as the new activity to display your results to. Here's the key method that does the GCD. It just does the recursive Euclid algorithm, real simple computation. Here's on pre-execute. On pre-execute prints a new message in the user interface thread saying, this new async task is starting up. And it indicates which async task it is because it knows its async task number. Here's the do in background method. This takes the number of iterations to run. It returns a Boolean. It goes ahead and generates, it iterates for the number of iterations that was requested, and it'll generate random numbers for each iteration. It checks to see if it's been canceled, to know if it should shut down. Otherwise, periodically it prints something. We don't print everything because we're going to do 10 million of these things, so every so often we print this stuff. And if we're all done with that loop, if this loop is finished, then we're going to do some really clever thing to see whether or not we are the last task running. And what we do here is we basically go and we say, remember we kept track of the number of tasks as an atomic integer. And so that m task count is the atomic integer count. And every time a task finishes, it decrements the count by 1. So let's say, for sake of argument, we had 2 tasks. So when the first one finishes, it'll decrement 2 by 1, atomically yielding 1. But 1 is not less than or equal to 0, so we're not the last one done. When the last one is done, this will end up being true, and it'll return true. So you'll notice that we call onProgressUpdate to periodically indicate what some given result is of the GCD computation. When publishProgress is called, it's going to go ahead and send that over to the user interface thread, and that will then print that value in the context of the user interface thread. When we're all finished, then, when a given task is done, then it goes ahead and tells the user interface, this is called in the user interface thread, it'll tell the main activity, it'll say, this async task is finished, and it'll indicate whether, it says it finished successfully because it was on post-execute, so it did not get canceled. And if we were the last task, then we tell the main activity, we're finished, so it can wrap everything up. If onCanceled gets called back, we do the same thing, except we indicate that we're finishing the async task after being canceled. So that's giving a different diagnostic message to the user if we're canceled versus whether we finish normally not being canceled. So those are basically the implementations of the various classes I talked about. It's really quite interesting. I strongly encourage you to take a look at that stuff. It'll help you for the assignment you're doing, and it provides a nice model to understand how async tasks work under the hood. So that concludes our walkthrough of the example, the GCD Async Task interrupted example that demonstrates how async tasks work and also demonstrates how you can interrupt async tasks and work with them as groups of async tasks using various clever Java programming techniques.